All right. Hello. Good morning, everyone. This is Professor Grenfell with Math 12 Statistics, and we're continuing today in Chapter 10, Section 3. And yeah, I had just done 10-12 and 10-13, and we're going to proceed on from there. In those exercises, we computed the standard error of the estimates using two different versions of, well, approximately equivalent formulas. A little bit of easier computation in this one over here. And the only difference here is due to different rounding within the problem. So after we compute the standard error of the estimate, go ahead and share my iPad display. After we compute the standard error of the estimate, we will then use that to form a prediction interval. Prediction interval is essentially just an interval estimate, kind of like a confidence interval, for the predicted y value. So instead of just using the regression line itself, we're going to form an interval that the y value could possibly be. All right, and that equation is a little bit horrendous. I'm going to break it down so that we can kind of decipher it a little bit better. The margin of error, which controls the fluctuation away from either above or below the predicted y value, is going to be t subscript alpha over 2. So it's a critical t value that we're using, times the standard error of the estimate, times this whole huge radical expression, 1 plus 1 over n plus n times x minus x bar, whole thing squared. And that is all divided by n times the sum of x squared minus the sum of x, whole thing squared. There it is. And just clean that up a little bit, like that, like so. And then the y value is predicted to be, or the interval that the y value could possibly be in, is y prime minus this margin of error and y prime plus this margin of error. And I'm not seeing anything on my screen, so let's see why that is. Okay, let's retry that. Of course, it never works when I'm actually recording, and when I do it, great. I forgot to record. So yeah, so I hope it showed up this time. Yeah, I see it on the screen, so hopefully we'll see it working. I apologize for not being able to show you it as I was writing it. Okay, so that is the formula that we're going to be using. It's a little bit of kind of, it seems a little bit complicated. There's a lot of elements to it, a lot of stuff that goes into it. But fortunately, we've already done a few of these things. So remember, we're going to first be making a scatter plot of all of our data points and seeing if there's a linear relationship. If it looks like there is, we'll go ahead and compute the correlation coefficient. All right, so we'll already do that and test it if it's a significant relationship. If it is, then we'll form the equation of the regression line. And then once we do that, those will be, those y prime values will be pretty close to the actual y values. Now, if we just say that's the predicted value, that's just a point estimate. And that prediction may or may not be accurate. In order to guarantee more accuracy or more likelihood that we'll have the actual y value in there, we want to then form a prediction interval. And so that's what we're going to do here. In order to use this more complex formula. We have to just do a few additional things. We have to find the sum of all of the x values, because that's in right here. We have to also, oh, sorry, let's not do red. We have to also do the sum of all of the x squared values. So we have to square the x values and then add them all up. And we also need x bar, which is, you know, the mean of all of the x values. So let's go back to the spreadsheet and speed up the process with a little bit of automation. Okay, go back to this one right here. All right. So let's use this version of the standard error of the estimate, but then let's go ahead and add an additional column over here for x squared. There. I don't like that, so let's center it. Actually, let's center this whole column, center aligned. There. All right. So for these values, I'm going to type in equals to this one raised to the second power. And it wants to autofill it for us. So let's just delete those ones though. All right. And we want to sum up all of the x squared values. So here I will want to type in equals to the sum, and it highlights the box for us. Perfect, right? So there we go. That's 82. And now we're going to go ahead right here. I'll use the computation space to form that standard error of the estimate. Oh, no, sorry, not the standard error of the estimate, the margin of error for this prediction interval. So that was t subscript alpha over 2, which in this case we have 4 degrees of freedom, and we want 95% confidence. So that gives us a critical t value of 2.776. We're going to do that times the standard error of the estimate. So times, I'll just go ahead and grab that value of it. And then times this one, the expression is going to be a little bit awkward. Let's go ahead and do it nonetheless. We've got the square root SQRT of this entire thing. Do 1 plus 1 over 6. That's okay. Then this other fraction we need to control a little bit better. So we'll do plus and parentheses for the top part and parentheses for the bottom part of it. So I'm going to go parentheses, parentheses, divided by parentheses, parentheses, and then close off all of the parentheses. But within this first one, n is 6. So we're going to do 6 times. We're looking at the particular x value being equal to 3. So I got to go times parentheses 3. Oh, hang on one second. I got to go ahead and fill in the square for the average of the x values. I'll just sneak and do that right here. It says error. That's appropriate. It's a margin of error. So here I have to get the average of all of these. And luckily enough, that's something that it says, oh, you probably want the average. Yeah, so there we go. All right. So that way I can plug that in when I do 3 minus, so that x value minus the average of the x values, I'll just click that in right there, and that whole quantity squared. So raise it to the second power. And then in the denominator of this, we're going to do 6 times the sum of the squared x values. So we want the total of this column. And then minus this one right here. Let's see. Oh, where was it? Oh, I didn't do that one either. I forgot the sum. So I'm going to abandon this one for a second. And, oh, hang on, I'm gonna abandon this for a second. And say equals the sum of all of these values right here, that whole range. Okay, so I forgot to do a couple of things. So let's go back to this formula. We'll write in this square right here. So that's the sum of all of the x values raised to the second power. So that's our margin of error. And then for the x value 3, that was actually one of our data values. We can come and look at the predicted value there. All right, so in this lower end, I'll say the predicted value. Oh, hang on, I have to type an equation, sorry. So I have to type equals, and then I'll take the predicted value for when x is equal to 3 and subtract the margin of error, and we'll enter that in. And then in this square right here, I'll say equals the predicted value for that particular x value being equal to 3, and plus our margin of error. So here, the prediction interval goes from 60.5 all the way up to 99.5 for the predicted, what was this, monthly maintenance rate for a machine that is 3 years old. So that will conclude example 10-14 from the exercises in the book. And we'll sign off. That will basically be a summary of all of chapter 10, section 3 for us. All right, so I'll see you.